QAG Academy members. This is Nissan. I'm trying to show you what I've done for the past several months. This is inverter without clamp that I demonstrated once. This is inverter with a clamp, and this is what I was going to show is interleaved inverter, and it looks quite bulky here, but works. Of course, I'll make a shorter, smaller version, and I'm working on this PCB, which will be a smaller version, and will be quite simple compared to what you see here. This right here is a driver with in series IGBTs. Each of them can tolerate 1200 volts, and I have them on both sides. That way it will sustain almost 5000 volts. Driver based on 2110 can hold at least 500 volts. Actually, this is 2113, which is 600 volts, and they're all isolated through transformers. This is the layer of capacitors which are connected in series, and the schematics there are right here, and these two sets of IGBTs and these two transformers, and here they are, and then they're connected according to the schematics and connected. These two sets of capacitors with diodes. They're actually taken from secondary windings of the transformers, and this is the load. We'll show you a demonstration, and I will upload some pictures of waves of each layer of IGBTs. So this is designed for QEG, so therefore I utilize 120 volts from my inverter here, and these are the batteries in parallel. Altogether it's 1.2 kilowatt. So let's start. So we're gonna start first driver. As you can see, they're working, and let's check the waves. I'll connect to primary. There you are. Yeah. All right, we'll slowly increase the voltage and observe the voltage on secondary right here. There's a load and there's a voltage. So far I have 75 here and 50 there. So the goal is to get to 80 volts so we can put it through. There you go. So we can put it through a 60 hertz inverter. So far it's 62 volts and 95 volts here. Let's increase it to 105. It's brighter, and it's 71. So let's increase it to 110, and we got 77 volts, and it's quite bright. So the idea is to get any voltage and transfer it into direct current, approximately 80 volts, so we can put it through 60 hertz inverter. Obviously, this inverter depends on voltage, not amperage. We if we increase the amperage, we will reduce the efficiency. So I put only 10 amps through this inverter, but you can get as much as 60 amps with 80 to 100 volts, so approximately 6 kilowatt. These huge transformers, each of them should be able to tolerate at least 4 to 5 kilowatt. So together it's almost 10 kilowatt. So as you can see, the first one is a little bit bigger than the second, but I didn't have the same size